You've spent your whole life looking at the moon and trusting its quiet certainty. No matter where you were or what kind of day you carried on your shoulders, that familiar face waited for you in the sky. It never turned away. It never shifted. It never revealed anything new. And yet, behind that calm expression lies a mystery that should never have been possible. The moon should rotate. Every world rotates. Rotation is the natural state of planets, stars, and almost everything held together by gravity. Stillness is the exception. And when something in space looks still, it usually means you haven't looked closely enough. That's why the title caught your attention tonight. Not because you were looking for a bedtime story, but because part of you wanted to understand how a world the size of the moon could stop spinning and stay that way for billions of years. You've lived long enough to know that simple explanations rarely fit the universe. And this mystery, the moon's unmoving face, is anything but simple. What you see each night is not a frozen world, but an illusion created by one of the most precise gravitational alignments in the solar system. The moon is rotating, just not in any way your senses were built to notice. Its motion is subtle, perfectly timed, and locked into a rhythm so exact that it has matched Earth's pull for longer than life has existed on land. That strange balance didn't come from peace. It came from violence, an ancient collision, molten rock cooling in orbit, and a slow, relentless negotiation between two worlds. A negotiation that continues even now, shaping your tides, your seasons, and even the length of your day. But the real reason you're here is simpler. You want that feeling you get when something finally makes sense. When the universe takes a puzzle you've carried for years and fits the last piece into place. There's a calm in that. A quiet kind of satisfaction. Tonight, you'll learn why the moon shows you only one face. You'll learn how Earth once grabbed hold of its rotation and slowed it to a near standstill. You'll learn why its motion became synchronized so perfectly that your ancestors, your parents, and you have all grown up seeing the same expression in the sky. And as the story unfolds, the noise of your day will soften. The tension will loosen. The stillness above you will start to feel less like a question and more like a companion. You clicked for the mystery, but you'll stay for the understanding. And by the time you close your eyes, you'll know exactly why the moon appears frozen and why its quiet balance is one of the most extraordinary motions in the universe. You've always seen the moon as steady, familiar, unchanging. But now that you know its stillness is only an illusion, you begin to sense the deeper question beneath that calm face. If the moon isn't truly frozen, then what exactly is it doing up there? And why has its motion remained hidden from you for your entire life? The answer begins with a simple idea, one that sounds almost too precise to be real: synchronous rotation. It means the moon spins, but at the exact same pace that it orbits Earth. One turn on its axis takes the same amount of time as one journey around our planet. 27.3 days. A perfect match. A perfect rhythm. And the reason you never see the far side is because that rotation and revolution cancel each other out from your point of view. From Earth, the moon appears locked in place, always presenting the same expression. But from above, or from the perspective of a spacecraft drifting through space, the truth is unmistakable. The moon does rotate, It just rotates at the only speed that keeps its familiar face pointed toward you. The moon spins, but only just enough to hide that it's spinning. This strange balance didn't happen overnight. There was a time long ago when the moon rotated far more quickly, completing a full spin in just a few hours. Its newly formed surface was still molten from the impact that created it, and its early motion was wild, untamed, and completely unsynchronized with anything else in the sky. But Earth's gravity had other plans. Picture the moon, not as a perfect sphere, but as a slightly uneven world, stretched and tugged by the gravitational pull of the much larger planet beside it. Just as the moon creates tides in Earth's oceans today, Earth once created tides within the moon itself, bulges of solid rock rising and falling under that relentless pull. As the moon rotated, those bulges lagged behind, never perfectly aligned with Earth's gravity. That misalignment created friction deep inside the moon's interior. And friction, even on a world made of stone, is a powerful brake. Night after night, century after century, the moon's rotation slowed. It lost a little energy, then a little more, until eventually its spin settled into the exact rate that matched the length of its orbit. One spin, one orbit, one face, locked in place. What you see now in the sky, a world that seems forever turned toward you, is the final result of billions of years of that quiet struggle. It's not that the moon stopped rotating. It's that it found the one speed where its turning and its orbit create the illusion of perfect stillness. This is synchronous rotation. And it's not magic. It's physics written in patience. NASA's Lunar Reconnaissance Orbiter has measured this synchronization with remarkable precision. Its instruments show that the moon keeps its orientation within fractions of a degree as it moves through space, the result of gravitational forces balancing one another with exquisite accuracy. If the moon rotated even slightly faster, you would begin to see a different region drifting into view. If it rotated slightly slower, the same thing would happen. The lock holds because any deviation pulls the moon back toward alignment. In a sense, the moon chooses to rotate at the only rate that allows its orientation to remain stable. It's not conscious, of course, but the physics of tidal forces create a natural preference, a lowest energy state. Once the moon slipped into that state, it stayed there. That's why you see only one face for 4.5 billion years. And that's why the illusion feels so complete. You're looking at the quiet end of a long equation, a balance so perfect it appears effortless. But when you understand how it formed, the simplicity fades and something else replaces it, a kind of wonder. Because the more you study this system, the more you realize how complex and beautiful it actually is. The Earth-Moon relationship isn't just a pair of worlds moving through space. It's a conversation written in gravity. Each world pulls on the other. Each world shapes the other's motion. And together, they settle into a rhythm that holds across geological time. That's the hidden truth beneath the moon's calm expression. And now that you've seen through the illusion, everything that comes next will make even more sense. The moon's stillness is the surface of something deeper, something vast, something ancient. But to understand the lock, we must understand the force. To understand why the moon moves the way it does now, you have to look beneath the illusion of stillness and into the forces that shaped it long before your world ever existed. You began to see the pattern in the previous part, but the real mechanism behind that perfect rhythm starts with the most fundamental rule in the universe. Every mass pulls on every other mass. That idea, so simple and so quiet, was written down by Isaac Newton centuries ago. His law of gravitation explains why apples fall, why planets orbit, and why the moon could never escape Earth's influence. And it also explains how the moon once glowed with heat created by Earth's gravity. According to Newton, the strength of that pull depends on two things: the mass of the objects and the distance between them. Earth, so much larger and heavier than the moon, reached out with a force strong enough to shape not just the moon's path through space, but the structure of the moon itself. Kepler refined this picture when he described how objects trace elliptical paths, speeding up when they're closer to the body they orbit, and slowing down as they move away. These rules seem dry at first, like equations written in old books. But when you apply them to the Earth-Moon system billions of years ago, they become alive. They become heat, they become motion, and eventually they become stillness. Picture the early moon once again, spinning fast, its crust soft, its interior warm. Even though it was small compared to Earth, it wasn't too small to be stretched. Gravity isn't gentle. It doesn't ask permission. When Earth pulled on the moon, the near side swelled outward slightly, forming a bulge that pointed toward our planet. The far side formed a second bulge, always opposite the first. These weren't oceans rising and falling like tides on Earth. These were tides of rock, solid but flexible enough under the stress of a planet pulling on them day after day. As the moon rotated, these bulges never aligned perfectly with Earth's gravity. Instead, they lagged behind, fighting to keep up with the moon's own spin. That tiny offset created friction deep inside the moon's crust and mantle. And friction, even at a scale this slow, becomes heat. Over millions of years, the moon's interior warmed from the constant kneading. The moon once glowed with heat created by Earth's gravity. That heat wasn't uniform. It pooled and flowed, making the moon's interior soften and shift, changing the distribution of its mass. Every shift altered the exact way the moon rotated, and each alteration fed back into the tidal forces pulling on it. It was a loop with no pause. With every rotation, the moon lost a little energy. That lost energy had to go somewhere, and the only place it could go was into its orbit. If a rotating object loses energy in one direction, it gains it in another. That exchange slowed its spin and pushed it slightly farther from Earth. A tiny change each year, a few centimeters. But over billions of years, centimeters add up to continents. This is the quiet engine behind tidal locking. Friction inside the moon acting as a brake, and the orbit absorbing what the rotation couldn't hold. Tidal friction is the universe's slowest engine. Those words from Dr. James O'Donoghue describe the principle perfectly. Slow, steady, relentless. Even now, the moon drifts away about 3-8 centimeters each year, a faint echo of the early braking that once reshaped its interior. NASA's GRAIL mission mapped the moon's gravitational field with exquisite detail and revealed the scars of this long process. Variations in density deep below the surface match the mathematical predictions of tidal heating. the moon's interior still carries the fingerprints of Earth's pull. Subtle differences in crust thickness, locked-in stress lines pointing toward Earth, pockets of ancient magma frozen in the paths gravity once forced them to follow. And the most surprising detail of all, the moon's center of mass is offset from its geometric center by nearly 2 kilometers. This tiny imbalance acts like a stabilizing weight, helping Earth maintain its grip. Even the smallest variation, a difference of a few millimeters in how mass is distributed, gets corrected by gravity over time. The system adjusts, shifts, and locks itself back into balance, again and again. That's how precise this relationship is. It's not just a dance, it's a negotiation. And it always ends with alignment. You may have grown up thinking the moon stopped spinning simply because it happened naturally. But the real story is deeper and more dynamic. The moon didn't calm down on its own. Earth reached out, grabbed hold of its motion, and gently squeezed the rotation out of it. Not abruptly, not violently, but through a steady pull that lasted hundreds of millions of years. Even now, the forces that created that lock haven't disappeared. Earth and moon continue to exchange energy. The tides rise and fall. The interior of the moon still shifts with microscopic adjustments. The orbit grows. The days on Earth lengthen. The negotiation never fully ends. And once you see this exchange, the stillness you thought you understood becomes something else. Motion slowed to silence. Energy transformed into stability. A world shaped not by chance, but by laws older than the oceans and older than the continents. Gravity keeps perfect records, and the moon is one of its most elegant pages. But was the moon always this quiet? If the moon seems calm now, it's only because you're meeting it at the end of a very long story. To understand how extraordinary its stillness truly is, you have to go back to the moment it entered existence. A moment defined not by silence, but by violence so immense it reshaped both worlds forever. In the earliest days of the solar system, Earth was not alone. It shared its orbit with another world, a Mars-sized protoplanet we now call Theia. The two bodies circled the sun in a delicate balance until the inevitable happened. Theia collided with the young Earth in an impact so powerful it melted crust, vaporized oceans, and launched entire mountains of molten rock into space. Out of that debris, the moon was born, and the world that emerged from this collision bore almost no resemblance to the moon you know today. It spun rapidly, completing a full rotation in just a few hours. Its mantle churned with heat. Its crust had not yet hardened into the familiar gray surface you see from Earth. Imagine that newly formed moon, glowing red-orange like a forge, turning so quickly that its surface strained under its own speed. At those early rates of rotation, the crust, thin, unstable, still trying to form, would have flexed and twisted as the moon spun, pulled in competing directions by its internal heat and Earth's overwhelming gravity. The moon once rotated so fast that its surface literally writhed under the strain, its topography bending as if the world were trying to tear itself apart. The molten mantle under the crust surged and shifted, unable to keep pace with the rotation. Earth's gravity acted on that molten interior, pulling it into tides of rock, raising and lowering the landscape in slow, massive waves. These weren't gentle motions. They were forces powerful enough to deform an entire world. And every time the moon rotated, those raised bulges fell slightly out of alignment, lagging behind the spin. That misalignment created enormous tidal heating. Heat generated not by the sun or by radioactivity, but by the constant stretching and relaxing of the moon's interior. The early moon was, in a very real sense, kneaded like dough by Earth's gravity. Over time, that kneading drained the moon's rotational energy. Every rotation slowed it a little more. Every cycle of deformation removed just enough momentum to draw the moon closer to synchronization. Slowly, the chaotic spin began to settle. The molten mantle cooled. The crust thickened. The internal heat of tidal flexing diminished, and the wild, unstable rotation that had once twisted the moon's surface into contorted shapes finally eased into the slow, steady spin you know today. If you could have watched that process unfold over millions of years, it would have looked like a spinning top losing speed. First rapid and unpredictable, then wobbling, then slowing, until finally locking into the single rhythm dictated by Earth's gravity. That lock, once formed, became self-reinforcing. Any attempt by the moon to rotate faster or slower created a gravitational pull that nudged it back into alignment. Over time, the moon's rotation became so stable that it pointed the same face toward Earth for billions of years. And yet the memory of that chaotic beginning is still written across the moon's surface and buried deep within its interior. NASA's GRAIL mission revealed crust thickness differences that match models of early tidal heating. Regions where the crust thinned show where molten rock once rose and fell under intense gravitational stress. Mascons, mass concentrations buried beneath the surface, mark the places where lava once pooled and cooled unevenly. These features aren't random. They're fossils of motion, the geological handwriting left behind by a world that once spun too fast for its own comfort. In the words of Dr. Maria Zuber, the moon's shape is a memory of its motion. And when you look at the moon now, calm, solid, quiet, you're seeing the stillness that came at the end of that long, violent transformation. Its surface no longer bends. Its tides of rock have settled. The molten mantle has solidified. What remains is a world that finally found balance after billions of years of losing energy to the force of the planet beside it. But even though the moon carries that memory on its near side, the full story was inaccessible to you for most of human history. The other half of this record, its forgotten hemisphere, remained hidden from every eye on Earth since the dawn of time. But half of that memory was hidden from us for millennia. For as long as humans have looked up, you have only ever seen one face of the moon. Every ancestor you've ever had, every civilization that ever rose or fell, every explorer, every dreamer, every wandering child staring upward from a dark field, they all saw the same familiar hemisphere, the same craters, the same seas, the same ancient patterns of light and shadow. The other side might as well not have existed at all. It lived entirely in imagination, in speculation, in myth. Until 1959, when a small Soviet spacecraft called Luna 3 curved around the moon and sent back the first grainy images of a hidden world no human had ever witnessed. Those photographs, blurry and imperfect as they were, revealed something astonishing. The far side of the moon did not look like the near side at all. It wasn't a mirror image. It wasn't even close. It was harsher, darker, older. Instead of wide, smooth plains of cooled lava, like the Maria that paint the near side, the far side was covered almost entirely in craters. It looked untouched, as if it carried the unbroken memory of every impact since the birth of the solar system. If the near side feels familiar and welcoming, the far side feels ancient. So ancient it borders on haunting. And the more we studied it, the deeper the differences became. The near side's crust is thinner, shaped by volcanic activity that resurfaced huge regions after its early history. The far side's crust is far thicker, almost double in some places, and far more rigid. The near side contains higher concentrations of radioactive elements that once generated internal heat, allowing lava to well up and fill its lowlands. The far side is poorer in those elements, colder, and more resistant to geological change. Chemically, structurally, and visually, the two hemispheres might as well be two different worlds fused into one. The far side is a record of impacts stretching back billions of years, a preserved museum of every cosmic event that struck it since the moon first cooled. It is, quite literally, the most pristine impact museum in the entire solar system. No wind, no rain, no flowing water, no atmosphere, no tectonic drift has ever softened it. What landed there stayed there. What scarred it remained. You are looking at the closest thing we have to the untouched surface of an ancient world. And at the far side's heart lies one of the largest impact structures ever discovered, the South Pole Aitken Basin. It spans more than 1,500 miles, nearly a quarter of the moon's entire diameter. It is so deep, so broad, so violent in origin that it excavated material from the moon's lower crust, or even its mantle. The basin is a scar of unimaginable scale, the kind you can only get from the early solar system when collisions were colossal and constant. Earth likely endured impacts just as massive, but our planet erased its ancient wounds through volcanism, tectonics, erosion, and life. The moon did not. It kept its memories. Modern missions have only deepened the mystery. China's Chang'e 4 lander and the Yutu-2 rover became the first spacecraft to explore the far side directly. They found signs of complex geology, unusual minerals, layered subsurface structures, and hints that the far side's interior evolved differently than the near side's. One of the most intriguing discoveries was a material with a composition unlike anything seen before, possibly remnants of the moon's deep interior thrown to the surface by ancient impacts. This isn't just a battered landscape. It's a geological archive, a library of the solar system's earliest chapters. While the near side was resurfaced by seas of molten rock that smoothed out much of its early history, the far side kept almost all of its scars intact. It is untouched in a way that few worlds are. Even Mars has winds. Even Mercury has temperature shifts that crack and reshape its terrain. But the far side of the moon is frozen in time, a silent monument to billions of years of cosmic events. And yet for most of human history, we had no idea this hemisphere was so different. We stared at the same face every night and imagined that the hidden side must look similar, symmetrical, gently shadowed. But symmetry is not the way of the universe. The moon is a world shaped by extremes, one face molded by volcanic heat, the other by uninterrupted bombardment. Why such stark asymmetry? The early theories ranged from tidal heating differences to internal temperature gradients to the influence of the Earth's gravitational field. Each idea added a piece to the puzzle, but none of them fully explained the divide until spacecraft began mapping the moon with high precision. What the data revealed was subtle but powerful. The near side, thinner and warmer in its early years, allowed magma to rise more easily. Lava flooded its lowlands, forming the dark seas we see today. The far side, with its thicker crust and colder interior, resisted that flow. Instead of smoothing itself through volcanism, it accumulated crater after crater after crater. Two hemispheres shaped by the same forces, but responding in utterly different ways. And when you understand that, the moon becomes more than the calm companion you grew up seeing. It becomes a world with history, with memory, with a story carved into stone on a scale too vast for a single human lifetime to comprehend. It becomes something you can almost feel, a reminder that even familiar things carry hidden depths. And the forces shaping these two faces never stopped. Even now, long after the chaos of the early solar system has faded into silence, the relationship between Earth and the moon is still changing. The lock you see in the night sky looks perfect and eternal, but perfection in the universe is rarely static. It evolves. It shifts. It breathes in slow, almost invisible ways. And if you know where to look, you can still see the imprint of that ancient gravitational negotiation happening right now. You don't need a spacecraft or a telescope to witness it. The evidence has been sitting quietly on the moon for more than 50 years. During the Apollo missions, astronauts placed small mirrored panels, retroreflectors, on the lunar surface. They look simple, almost like forgotten hardware, but they allow scientists to measure the distance between Earth and the moon with astonishing precision. Laser pulses fired from Earth strike those mirrors and return with a delay so tiny it must be measured in trillionths of a second. And from that faint echo, one of the most surprising truths emerged. The moon is drifting away, slowly, steadily, and relentlessly. About 3.8 centimeters every year. It's not much, barely the width of your finger, but across millions of years, it reshapes the entire system. As the moon moves outward, the gravitational relationship between Earth and its companion shifts. And here on Earth, you feel that change in the length of your own day. The more the moon drifts away, the more Earth's rotation slows. It's the same exchange of energy that once locked the moon's rotation, still unfolding long after the initial synchronization was achieved. If you traveled 1 billion years into the past and looked down on Earth, you would see the planet spinning faster, with days shorter than the ones you live through now. A day on Earth used to be 22 hours, not because the Earth was younger, or hotter, or more chaotic, but because the moon had not yet pulled enough rotational energy out of it. Little by little, the tide slowed Earth's spin. Every wave that rises and falls transfers a bit of energy from Earth's rotation into the moon's orbit. Over the course of a single night, it's nothing. Over the course of geological time, it's everything. Today, this energy exchange is immense. Tidal friction dissipates roughly 3.7 terawatts, an almost unimaginable power spread thinly across oceans and coastlines, silently turning rotational momentum into heat and pushing the moon a little farther out with each passing year. This is gravitational aging. Not dramatic, not violent, but a slow reshaping of the system, a maturation of a relationship that has lasted since Earth first cooled enough to hold an ocean. You live in a cosmic moment where the balance of forces still feels steady, almost timeless. But the system is still evolving. The moon's gradual retreat means your days are getting longer by about 2 milliseconds every century. You won't feel it. No one does. But the Earth does. The tides do. Life does. And millions of years from now, the length of a day will be noticeably different, not because of anything humans built or broke, but because the moon continues to pull on the spinning world beneath your feet. This drift has consequences beyond the length of a day. It alters the gravitational feedback loop between Earth and Moon, softening the tides, reducing the energy transferred through the oceans, and slowly adjusting the fine-tuned balance that has shaped Earth's climate and stability. None of this happens quickly. Nothing about this relationship ever does. But the changes accumulate. They create patterns. They carve stories into time. What's remarkable is not just that Earth is still slowing the moon, or that the moon is still slowing Earth. What's remarkable is that you are living inside a system that looks frozen while being anything but. The moon has not stopped moving. Earth has not stopped adjusting. The orbits, the rotations, the tides, all of them remain in conversation, exchanging energy across the gulf of space in whispers so faint you only hear them by looking backward across millions of years. And this slow evolution adds another layer of wonder to the illusion you see each night. The face of the moon may remain fixed toward you, but the distance between you and that face is widening. The rotation of your world is stretching. The tides are shifting. The balance is still active. The negotiation continues. It always has. Understanding this brings you to the deeper truth hidden inside the system. The Earth-Moon pair is not done evolving. It's still settling into new rhythms you cannot feel moment to moment. But over the lifetime of a planet, these changes matter. They shape coastlines. They shape climates. They shape the length of days and nights. They shape the future. This is the payoff of everything you've learned so far. The Earth-Moon system is alive in its own slow way. Even now, it is gently, quietly, constantly shifting. But what would happen if that perfect rhythm, the one that keeps the same lunar face turned toward you, were to change? What if the lock loosened? What if the moon broke free from its perfect rhythm? If everything you've learned so far makes the moon seem stable, predictable, and permanently locked into its gentle rhythm, then this part of the story will shift your perspective. Because the lock is strong, but it is not unbreakable. It has held for billions of years, but the universe never grants guarantees. And when scientists model what would happen if the moon's rotation changed, even slightly, the results reveal just how delicate the balance truly is. NASA has run simulations exploring alternative histories, theoretical futures, and low-probability cosmic events. These scenarios ask a simple but profound question. What if the moon started spinning again? Not fast, not wildly, not even noticeably to your eyes. Just enough that its rotation no longer matches the length of its orbit. Just a tiny deviation from synchronous rotation. The models show something remarkable. Even a small change would disrupt the gravitational feedback loop between Earth and Moon. The moon's locked face would begin to drift. Slightly at first, a flicker at the edge of sight. Then over months or years, The familiar pattern of craters and Maria would shift across the sky. You would see regions no human has ever seen with the naked eye. But the moon's appearance would be the least of your concerns, because the effects cascading from that small change would ripple across the entire system. Gravitational tides depend on alignment. When the moon is locked, the tidal bulge on Earth remains stable, rising and falling with consistency. But if the moon's rotation slipped, the timing of the tides would drift. Their strength would vary in unpredictable ways. Their pattern would unravel. In the simulations, just a 1% change in rotation could destabilize Earth's tides by 15%. That may sound small, but it would reshape coastlines. It would alter the flow of warm and cold currents. It would disturb the distribution of heat across the oceans. Earth's climate depends on those flows. When they become unstable, climate becomes unstable too. Weather patterns shift. Storms intensify. Regions that were predictable for centuries begin to fluctuate. You wouldn't see this overnight, but in the span of decades, the effects would become undeniable. A system that has guided the planet's seasons for billions of years would suddenly be uncertain. The moon itself would feel the consequences as well. As it rotated out of sync, the gravitational pull on its interior would increase friction and stress. Tidal heating would spike. The crust, which has been quiet for so long, would begin to move again. Moonquakes, already measured by Apollo seismometers, would grow more frequent and more intense. They wouldn't destroy the moon, but they would shake loose ancient faults, reopen long dormant cracks, and perhaps even trigger localized collapses within its fractured crust. The moon would brighten and dim in subtle ways as its reflectivity shifted. New angles, new shadows, new ways for sunlight to catch on the highlands and the edges of craters. For the first time in human history, the moon would no longer be the steady companion you've always known. It would be active, restless, unpredictable, and those changes would echo back to Earth. Even more significant is what happens to Earth's axial tilt. Right now, the moon acts like a stabilizer, damping the wobble of Earth's tilt and keeping the seasons consistent. Without the moon's precise gravitational grip, that stability weakens. The tilt could begin to drift, perhaps slowly at first, then more dramatically over thousands of years. In extreme models, Earth's axis swings like Mars's does, shifting so widely it turns deserts into polar plains and ice sheets into fertile coastlines. Civilization relies on a stable world. That stability relies on the moon. But here's where the story becomes even more fascinating. The simulations don't end in chaos. They end in restoration. The forces that originally locked the moon would still exist. Tidal friction, gravitational torque, and the natural search for the lowest energy state would continue working. Over millions of years, the system would settle again. The moon would relock, just as it did billions of years ago. One face would return to looking down on Earth. The tides would stabilize. Earth's tilt would calm. The system would heal. This long cycle, disruption followed by relocking, reveals something important. The lock is not a permanent state. It's a dynamic one. It can be disturbed, broken, reformed. You are living during one of its long periods of quiet. There were other possibilities, and there will be others in the distant future. When you look at the moon now, its stillness seems absolute. But underneath that quiet, there are forces still at work, still exchanging energy, still adjusting and recalibrating the balance between two worlds. You wouldn't notice it in a lifetime. You wouldn't notice it in 1,000 lifetimes. But the system breathes in slow cosmic rhythms. Just knowing that gives the moon a new kind of presence. It's no longer the silent disk you grew up seeing. It's a participant in a long dialogue with Earth. A dialogue written in gravity, expressed through tides, and measured in millions of years. And it leads you to one more truth. Even now, while it seems frozen, the moon is moving. Even after everything you've learned, the slowing of rotation, the drifting orbit, the delicate exchange of energy, there is still one more motion hidden beneath the moon's calm expression. It's subtle, gentle, almost imperceptible, but once you understand it, the moon's stillness becomes even more beautiful. Because the moon doesn't simply face you. It wavers, leans, nods, and breathes in a slow cosmic rhythm. And through that rhythm, it reveals just a little more of itself than the locked face you've always known. This subtle motion is called libration, and it is the reason you can see not just half the moon, but 59% of its surface. Nearly 10% of the lunar world is revealed to you only because of this gentle oscillation, a motion so soft and slow it feels almost alive. The moon breathes through gravity. The first kind of this motion is libration in longitude. It happens because the moon's orbit around Earth is not a perfect circle, but an ellipse, sometimes closer, sometimes farther. When the moon is closer to Earth, it moves slightly faster in its orbit. When it is farther away, it moves more slowly, but its rotation remains steady. That mismatch means that from time to time, the moon seems to turn slightly on its axis, allowing you to peek a bit around its eastern or western limbs. Over the course of an orbit, the moon almost seems to rock from side to side, offering glimpses of terrain normally hidden from view. These small openings at the edges are the first invitation to understand its true motion. The second kind of motion is libration in latitude. This one comes from the moon's axis being tilted slightly relative to its orbit, just a few degrees, but enough to matter. As the moon moves around Earth, that tilt causes it to nod gently up and down. Across a month, it reveals a bit over the northern pole, then a bit over the southern pole. If you watch the moon day after day without interruption, you would notice the face tilting, rising and dipping ever so slightly, like a slow bow written into the lunar rhythm. The third type, diurnal libration, comes from your own position on Earth. As Earth rotates, you observe the moon from slightly different angles over the course of a night, once from the eastern horizon, once from the western. Your shifting vantage point lets you peer a little around one edge, then the other, contributing a final small piece to the puzzle. The moon doesn't just move. You do. And that creates its own subtle widening of your view. When all three forms of libration blend together, they create a gentle rhythmic motion that lets you see almost 60% of the lunar world, even though the moon remains tidally locked. It's a reminder that stillness is never truly still, not in a universe of gravity, motion, and shifting perspectives. Yet libration is not perfectly smooth. It contains tiny irregularities, subtle deviations that are the fingerprints of the moon's interior. These variations come from mascons, mass concentrations buried beneath the surface. Formed by ancient volcanic activity or colossal impacts, these dense pockets of material tug back against gravity in uneven ways, creating a slight wobble as the moon rotates. You can't see these mascons directly, but you can see the effect they have on the moon's dance. The wobble is small, but it is real, and it adds another layer to the moon's hidden motion. NASA's Lunar Reconnaissance Orbiter watches these motions with extraordinary precision. It measures changes in the moon's orientation to tiny fractions of a degree. The GRAIL mission, mapping the moon's gravitational field, revealed how mascons distort the balance of forces and how those distortions subtly alter the moon's rotation. These missions confirm what astronomers long suspected. The moon's motion is not a static lock. It is a dynamic, ongoing conversation between gravity and mass, rotation and orbit, alignment and imbalance. This is why the moon's face feels both familiar and strangely alive. On first glance, it's steady. But when you look deeper, you see the edges shifting, the poles rising and falling, the world turning in a slow, hypnotic rhythm. Libration gives the moon a pulse. It gives the illusion of stillness a heartbeat. And there's something soothing in knowing this, something peaceful in the idea that a world can be both stable and gently moving, not frozen, but balanced. This quiet motion mirrors the rhythms in your own life, the push and pull, the slight adjustments, the way you shift, settle, quiet yourself at the end of a long day. The moon is not motionless, it is poised. And that poise is what makes it such a calming companion in the sky. Once you understand libration, you begin to see the moon differently. You don't just see a face. You see a world turning in slow breath. You see gravity sculpting motion like an artist shaping clay. You see the delicate balance that lets you glimpse just a little more than half of that ancient sphere. And you understand why scientists call libration one of the most beautiful natural rhythms in the solar system. To understand this perfection, we must ask how it began. Once you begin to see how the moon moves, how it breathes through gravity, how it sways through libration, how it maintains its delicate orientation, it's natural to wonder whether all of this is rare or inevitable. Did the moon fall into this rhythm by chance, or is synchronous rotation simply what happens when worlds orbit one another long enough? The truth is somewhere in between. Tidal locking is common in the solar system, but the Earth-Moon relationship stands apart in ways that make it one of the most extraordinary pairings in planetary science. If you look outward at Jupiter, you'll find its largest moons, Io, Europa, and Ganymede, all locked in synchronous rotation. They keep the same face toward Jupiter, just as the moon does toward Earth. Pluto and Charon are locked to each other as well, turning in tandem like dancers whose hands never separate. Even Mercury teeters on the edge of a tidal lock with the Sun, held in a 3.2 resonance that ties its rotation and orbit into a repeating cycle. Tidal locking, in other words, is a natural consequence of gravity. Give any pair of bodies enough time, and friction will slowly grind their rotations into alignment. But Earth and the Moon are not simply another example of this rule. They are something much more unusual. Most moons are small compared to the planets they orbit, tiny companions circling enormous hosts. Our moon, however, is enormous relative to Earth. It is more than a quarter the diameter of its planet. No other planet in the solar system has a moon even close to this size ratio. In fact, the moon is so large compared to Earth that many scientists argue the two worlds form something like a binary system, a pair of bodies orbiting a shared center of gravity. The Earth-Moon pair is closer to a binary planet than a planet and a moon. This unusual size relationship is part of what makes the present synchrony so remarkable. It also makes it fragile. When scientists run millions of statistical simulations, testing how often a system like ours would settle into a stable synchronous rotation, the answer is startling. The range of conditions that allow this balance is incredibly narrow. Too close, and the moon would spiral inward toward destruction. Too far, and the gravitational tug would weaken enough for the lock to break. Too small of a moon, and the tidal forces wouldn't be strong enough to slow its spin. Too large, and the planet itself would wobble uncontrollably. Our moon fits the stability range by a razor-thin margin. It is one of the reasons Earth's climate has remained stable enough to support life for billions of years. It is one of the reasons the seasons don't drift chaotically. It is one of the reasons ocean tides follow a steady rhythm. It is one of the reasons Earth is, in so many ways, a calm world in a violent universe. The synchrony itself is not delicate, though. Once the rotation and orbit match, the lock becomes self-stabilizing. If the moon tries to rotate a little faster, gravity pulls back on the bulge in its crust and slows it down. If it rotates a little slower, that same bulge falls ahead of Earth's pull and gravity tugs it forward. This restoring torque acts like a cosmic spring, always nudging the moon back into perfect alignment. The system is exquisitely tuned, not because it formed that way, but because gravity corrects every deviation, every perturbation, every slight imbalance. Synchrony is not static. It is reinforced every minute of every day. The more you understand this, the more the moon's calm presence in the sky begins to feel profound. You're not looking at an accident. You're looking at the end point of billions of years of adjustments, each one driven by forces too large to see, too steady to feel, and too patient to rush. You're watching an equilibrium that was earned, not given. It's comforting to think of the moon as a companion that has always looked the same. But in reality, what you see now is the result of an almost impossibly precise exchange of energy between Earth and its partner. A balance that wouldn't exist if the moon were slightly lighter or heavier, closer or farther, softer or harder, hotter or colder. Other worlds fall into tidal locks too, but none with this exact size, this exact distance, this exact history. None with this delicately preserved synchrony that shapes an entire planet's stability. And when you understand that synchrony is not simply a consequence of physics, but a conversation between two worlds, the moon becomes something more than a bright shape in the sky. It becomes a record of what the universe can achieve when forces tug on each other for long enough, shaping chaos into rhythm and motion into stillness. But perfection often hides a violent beginning. To understand the moon's perfect synchrony, you have to go back to a time when nothing in the solar system was calm. The skies were crowded with newborn worlds, half-formed planets, and drifting fragments that had not yet settled into stable orbits. Gravity was sorting everything, pulling, scattering, merging, and destroying. Planets didn't glide peacefully around the sun the way they do now. They lurched, they collided, they devoured their neighbors. It was a time defined by chaos, heat, and violence so extreme it is difficult to imagine from the quiet distance of the present. Earth was young then, hot, restless, and unstable. Its crust had barely begun to cool, and its orbit was still influenced by the leftover debris of creation. Encircling the sun along a nearby path was another world, roughly the size of Mars, moving just close enough and fast enough that a collision became all but inevitable. We call this world Theia. When the two bodies met, they did not simply bump or merge. They struck each other with an energy almost beyond comprehension, around 10 to the 39th power joules. Enough force to vaporize continents, enough force to melt both crusts into a global ocean of magma, enough force to tear Earth open and send entire mountains of molten rock into space. The impact was not just catastrophic, it was defining. For a brief time, Earth was no longer a single planet. It was a swirling system of vapor, molten stone, and shattered fragments expanding outward in a cloud that glowed brighter than any volcano or fire that would ever exist again. That vapor formed a halo of debris encircling the ruined world, a ring not unlike the ones around Saturn, but composed entirely of Earth's own torn-away material. Inside that ring, gravity began its work again. Collisions became mergers. Mergers became clumps. Clumps became spheres. And slowly, from the wreckage, the moon took shape. At first, it existed as a molten world, still radiating the heat of the impact, turning slowly within the debris cloud that had given birth to it. It was not alone. Some fragments fell back to Earth. Others were ejected into the sun, and still others drifted away forever. But the largest remnant remained in orbit and cooled into the body you now see in the night sky. One model of this early stage, called the synestia model, suggests that Earth itself briefly expanded into a vast torus of molten vapor, a swollen, spinning structure where the boundary between planet and disk disappeared. In this view, the moon condensed inside that enormous cloud, forming not from a thin ring, but from the very atmosphere of a vaporized world. Whether the moon formed in a ring or within a synestia, the outcome is the same. It is made from the same ancient material that once belonged to Earth's crust and mantle. And that connection runs deeper than shape or structure. When scientists examine lunar rocks brought back by Apollo astronauts, they find something astonishing. The isotopic fingerprints, the unique ratios of oxygen isotopes that identify where a rock came from, are nearly identical between Earth and Moon. So identical that they are impossible to separate. This matching is one of the strongest pieces of evidence for the impact theory. It tells you that the Moon is not an alien world captured by Earth's gravity. It is a piece of Earth itself, reforged in orbit. Even the Moon's asymmetry traces back to those violent early days. The near side's crust is thinner, its interior once hotter, more fluid. The far side's crust is thicker, more rigid, shaped by a colder interior and fewer volcanic floods. Why this difference? Because the freshly formed Moon was still close enough to Earth for gravitational heating to shape one hemisphere differently than the other. The near side remained warm longer, its molten interior rising and falling with Earth's pull. The far side cooled faster, hardening into an ancient shield. The crustal asymmetry you see today is not an accident. It is a fossil of heat. Heat generated in the aftermath of the Theia collision. Imagine that still molten moon, freshly formed, glowing like iron pulled from a forge, locked in place around Earth, before slowly drifting outward over billions of years. Imagine the surface cooling, cracking, and thickening as the molten interior stabilized. Imagine the tidal forces sculpting its rotation, slowing it, locking it, freezing its orientation into the familiar face you know. All of that motion, all of that heat, came from the original impact. A single moment of cosmic violence shaped billions of years of gentle moonlight. And when you look at the moon tonight, calm and pale and perfectly still, you are seeing the end of that story. A world formed in fire, born in catastrophe, now hanging in the sky as if it had never known anything but quiet. A companion that survived the most extreme forces the early solar system had to offer, and somehow found balance at the end of it all. Every crater, every ridge, every frozen sea of basalt is part of that story. Every difference between the near side and the far side is a signature of that early heat. Even the synchrony of rotation, the stillness of the face looking back at you, is a delayed consequence of the impact. The moon's calm presence is the final chapter of a history written in destruction. From that violence came the stillness we see tonight. The moon feels eternal to you. It looks like something that has always been there and always will be. A quiet witness above every generation that has ever walked the earth. But even the most stable relationships in the universe are not truly permanent. Gravity is patient, but it is never finished. The same forces that once slowed the moon's rotation and pulled it into synchrony with Earth are still at work today, slowly altering the system in ways too subtle for human senses to detect. If you stretch your imagination across billions of years, you begin to see the long-term evolution of the Earth-Moon partnership. The moon is still drifting outward at nearly 4 centimeters per year. Earth is still surrendering tiny fragments of its rotational energy to the tides. The length of a day grows by milliseconds each century, and although you will never feel it, the planet keeps time on a scale far larger than human life. Follow that trend long enough, and something remarkable happens. In roughly 50 billion years, long after humanity, oceans, continents, and even the memory of Earth as you know it have disappeared, the Earth-Moon system will reach a stage where both worlds become mutually locked. Not just the moon, but Earth as well. In that distant future, a single day on Earth will last as long as one lunar month does now. 27.3 days of slow turning, where the sun rises only once every 4 weeks. Nights that last entire seasons, seasons that last entire cycles. And the moon itself will stop its gradual retreat once the gravitational energy exchange reaches a perfect balance. Instead of drifting farther away, it will settle into a stable distance, hovering over one hemisphere forever. Imagine a world where one side of Earth sees the moon fixed in the sky like a pale lantern that never moves, never sets, never rises, its face permanently suspended above the same landscapes. The other hemisphere would never see the moon again. Generations born under that sky would know stories of a companion they could never witness, a presence lost to the turning of time. In that far future Earth, tides would follow a single, immense rhythm. The pull of the moon would fall into step with Earth's rotation, creating one vast, slow rise and fall across coastlines. Climate patterns would shift in unfamiliar ways. Weather cycles would stretch and drift. The yin-yang balance of night and day, light and darkness, would stretch across weeks instead of hours. It would be a quieter world, a slower world, a stranger world. But none of this will remain long enough to fully mature, because a larger story unfolds behind the scenes. The sun, the great clock at the center of the solar system, has its own lifespan and its own ending. In about 5 billion years, long before the Earth-Moon pair can complete their long drift toward mutual lock, the sun will swell into a red giant. Its surface will expand outward until it engulfs Mercury, Venus, and possibly even Earth. The heat will boil the oceans, strip away the atmosphere, melt the crust, and erase every structure ever built, every shoreline ever shaped, every memory ever carried by the planet. The moon's drift, Earth's slowing rotation, the gradual approach toward a future tidal lock, none of it will reach its final form. The sun's transformation ends the system long before it can settle into true stillness. And yet there is something quietly beautiful in that unfinished journey. The Earth-Moon story is not defined by where it ends, but by the path it has taken. The synchronicity you see today is temporary, but the harmony it creates right now, the stable tides, the dependable phases, the familiar glow, is real. It shapes your world in ways you feel without noticing and depend on without thinking. The moon doesn't need to last forever for its presence to matter. There is a kind of melancholy in knowing that even the most familiar things in your sky are temporary. But there is calm in it too. Because when you understand the scale of cosmic time, you realize that permanence was never the goal. Balance is. Harmony is. And for this moment in the vast sweep of the universe, the Earth and Moon share a balance that has allowed life to flourish, oceans to breathe, and the cycles of night and light to unfold with gentle consistency. The moon has already survived fire. It has already found stillness. It has shaped the length of your days and the rhythm of your tides. Whether or not it makes it to that distant future, tidal lock does not diminish what it is right now, a companion whose presence brings order to your world. And yet, you are here, watching this dance unfold. When you look at the moon, it feels like a companion, quiet, steady, comforting. But what it provides is far deeper than comfort. Its presence shapes the very stability of your world. Earth may look peaceful from space, but its balance is delicate, held in place by angles, rotations, cycles, and gravitational tethers that are constantly negotiating with one another. And among all those forces, the moon is one of the most important stabilizers Earth has ever had. The core of this influence begins with axial tilt. Earth doesn't spin upright. It leans at about 23.5 degrees. And that tilt is the reason seasons exist. But without the moon, that tilt would be unpredictable. Over millions of years, gravitational nudges from other planets, especially Jupiter, would tug on Earth's axis, causing it to wobble wildly. You would see the poles shift, the equator wander, climates collapse, ice ages arrive abruptly, deserts bloom where tundra once stood. Entire ecosystems would struggle to adapt. Without the moon, Earth might wobble like Mars. Mars is a world with no large moon to steady its orientation. Its axial tilt swings between 15 and 35 degrees across long cycles, enough variation to rewrite its climate over and over again. Frozen poles thaw. Dust storms rage for months. Environments flip in and out of habitability with each shift. Earth could have been that world. Unsteady, unpredictable, wandering through climatic extremes. But the moon steadies it. The gravitational pull between Earth and its companion dampens the wobble, holding the axis within a much narrower range. That subtle restraint has allowed Earth's climate to remain relatively stable for billions of years. Stable enough for oceans to form, for continents to settle, for life to flourish. This stability extends into the smoothing of Earth's climate. Tides move vast volumes of water across the globe twice each day, circulating energy through the oceans. This movement helps distribute heat, keeping the planet from falling into extremes of hot and cold. The moon is the dominant force behind these tides. Without them, the oceans would be more stagnant, less mixed, more prone to trapping heat or cold in isolated regions. Climate would grow harsher. Patterns would break. The gentle rhythm of rising and falling water, quiet as it feels from shorelines, is part of the planet's long-term balance. The moon also shapes the consistency of Earth's seasons. A stable axial tilt means winter, spring, summer, and fall unfold with dependable timing. It means migrations, flowering seasons, ocean currents, and atmospheric cycles can develop patterns that last for millions of years. Earth's entire biosphere is synchronized to those rhythms. Creatures migrate according to lunar cues. Corals release their eggs under certain phases of moonlight. Tidal pools create habitats where life cycles are tied directly to the pull of the moon. And even within the human body, ancient biological traces remain. Subtle influences of the lunar cycle on sleep patterns, hormonal rhythms, and emotional states. You're connected to the moon more deeply than you realize. Life evolved under its light and its pull. The tides shaped coastal ecosystems that became cradles for early life. The steady seasons shaped forests, prairies, and oceans. And the moon's gravitational leash prevented Earth from spinning into climatic chaos before life ever had a chance to take hold. It's easy to forget all of this when you see only the moon's gentle glow. It doesn't appear to be restraining anything. It doesn't look like a force holding your world steady or protecting it from planetary wanderings. It floats with such quiet presence that it feels more like a symbol than a mechanism. But behind that calm expression lies a stabilizing force, powerful enough to keep the planet's orientation steady for billions of years. The moon's presence is one of the reasons Earth is a world where cycles repeat, where patterns endure, where life can adapt without being shattered by sudden shifts. And the influence extends beyond geology and climate. In deep time, the moon shaped human culture itself. Agriculture grew out of recognizing patterns, seasons, tides, cycles of light. Navigation across oceans relied on its glow and the tides it created. Stories, myths, calendars, religions, all found meaning in its phases. Even today, without thinking about it, you live in a world structured around rhythms the moon helped establish. Its stillness is not silent. It speaks through tides. You don't feel these stabilizing forces from one moment to the next. You don't wake up sensing the moon's pull on the oceans or the tilt of your planet being held in place. But every gentle sunrise, every predictable season, every calm coastline is part of the quiet balance built into the Earth-Moon system. And now that you see how much the moon contributes to that balance, its presence in the sky becomes something deeper than a familiar shape. It becomes a reassurance, a constant, a quiet anchor for an entire world. Its stillness is not silent. It speaks through tides. After traveling through billions of years of motion, impact, heat, and gravity, you arrive again at the simple truth of what the moon feels like when you step outside at night and look up. All those forces, synchronous rotation, tidal breaking, orbital drift, axial stabilization, they exist on scales so vast you cannot feel them directly. And yet, somehow, the moon touches your life in ways that have nothing to do with physics textbooks or mathematical models. It touches you through presence, through familiarity, through the quiet reassurance of something that has looked the same for your entire life. You carry your own motions through the world. Work, responsibility, decisions, memories, hopes, the steady rotation of days turning into nights. Life can feel complicated, chaotic, fast in ways you can't always control. But when you look at the moon, the pace changes. The moon takes something as enormous as cosmic mechanics and translates it into a moment of calm. A reminder that even in a universe defined by motion, there are rhythms gentle enough to rest inside. For countless generations, the moon has served as an anchor for the human mind. Not because people understood tidal locking or gravitational equilibrium, but because something in its patient glow felt trustworthy. The moon was the first clock, the first calendar, the first guide across open water. It marked time long before numbers did. It told people when to plant, when to harvest, when to rest. And even now, in a world full of artificial light and digital timekeeping, something inside you responds to its cycle. There's a reason a full moon feels different than a crescent. A reason your eyes linger on it without thinking. A reason children point upward with wonder, and adults pause for a moment of quiet. The moon has a way of softening the noise of the day, of slowing your breathing, of giving your thoughts a place to settle. It doesn't ask for attention. It simply receives it. And somewhere in that exchange, your mind finds equilibrium. When you see the moon unchanged from one night to the next, it becomes more than a celestial object. It becomes a symbol of consistency, a reminder that some things move slowly enough for you to feel them, that some rhythms in the universe are gentle, steady, and safe. The moon's phases unfold with absolute patience. Its path across the sky follows a familiar arc. Its light, dim but unmistakable, reaches you with the same softness night after night. In a world where so much shifts without warning, the moon becomes a quiet promise that not everything does. And when you understand the science behind that steadiness, the tidal lock, the gravitational balance, the billions of years of motion settling into a single calm face, it makes the experience richer, not colder. Physics doesn't remove the poetry, it deepens it. Because the more you learn about everything that had to happen for the moon to become this reassuring presence, the more its calm feels earned. It becomes a companion shaped by the universe's vast forces. yet gentle enough to meet you where you are. You might not think of celestial mechanics when you look up at it. You might not think of ancient impacts or internal heat or drifting orbits, but you feel the result of all those things. You feel it in the quiet of a night walk, in the subtle ease that comes when your mind finally unwinds, in the way the world feels just a little more anchored when that pale circle rises. Because this story isn't only about the moon, it's about you. The moon's rhythm becomes part of your rhythm. Its steadiness becomes part of your balance. Its quiet motion becomes a reminder that even in a universe full of forces beyond your control, there are places where you can rest, breathe, and simply be. You are part of this relationship too, not through gravity or orbital mechanics, but through awareness, through the way you carry its presence with you, through the way you look up at it at the end of a long day and feel something inside you settle. And as the night deepens, the story quiets too. You've traveled a long way tonight, from the illusion of stillness to the hidden rhythms beneath it, from the moon's wild beginnings to the quiet balance it keeps now. And as you arrive at the edge of this story, you begin to feel something that has very little to do with science and everything to do with the way your mind softens when the world finally grows quiet. The moon above you looks calm, but now you know the truth concealed inside that calm. You know about the rotation slowed by tides, the orbit stretched by the exchange of energy, the gentle swaying of libration that reveals more of the lunar surface than you ever realized. You know that its stillness is a balance, not a pause, a negotiation between forces so old and so patient that they have shaped the sky for billions of years. You know that the moon breathes through gravity, that its locked face is the consequence of countless cycles of heat, friction, and time. You know that its drift outward lengthens your days, that its tug stabilizes Earth's axis, that its presence keeps climate steady and seasons predictable. All these motions, small, subtle, ancient, have woven themselves into the rhythm of life on your world. And yet, when you step outside on a quiet night and lift your eyes, none of that complexity enters your thoughts. What you feel instead is peace, something steady, something familiar, a light that has watched over every moment of your life and will continue watching long after this night passes. It's remarkable to think that a world born from cataclysm, shaped by forces strong enough to melt planets, now shines with such gentle calm. The violence that once tore Earth open turned into the balance that steadies it. The heat that once churned inside the moon cooled into the solid face you know. The chaos that spun the young solar system into collisions eventually settled into the slow, predictable dance that guides tides and seasons and the rising of each night's light. Ancient violence became quiet harmony, and in that harmony, you find your own sense of rest. The same physics that governs stars and planets also gives you this feeling of order, this reassurance that some things move too slowly to ever surprise you. The moon rises, the moon sets. The phases change in their familiar sequence. And even though everything in your life shifts and rearranges itself over time, this rhythm remains. A reminder that not all change is sudden, not all motion is loud. The more you understand these cycles, the softer the world feels. You begin to sink into the knowledge that the universe is not chaotic noise. It is patterned, structured, patient. It keeps time with a precision far older than any clock humanity has ever built. Every orbit, every rotation, every gravitational pull is part of a cosmic metronome that has never missed a beat. Carl Sagan said, "Even in silence, the universe keeps time." And when you look at the moon, that truth feels unmistakable. You may not hear the ticking of that ancient clock, but you see its marks everywhere. In the tides that rise and fall with perfect reliability, in the phases waxing and waning on a schedule older than language, in the seasons arriving with such consistency that entire civilizations have been built upon their predictability. These patterns are quiet, but they are not fragile. They are dependable enough to cradle whole worlds. Tonight, you're part of that quiet. You're listening to the same gravitational story the Earth and Moon have been writing together since the birth of the solar system. And even though your life moves on a much smaller scale, with its own challenges, its own rhythms, its own moments of imbalance, the moon reminds you that stability can be found in slow adjustments, in gentle corrections, in the steady pull toward equilibrium. Let yourself feel the safety in that. Let your mind rest in the knowledge that the forces shaping the universe are not hurried. They do not rush. They do not demand. They move with a patience so deep that it becomes calming to anyone who understands it. You are surrounded by cycles that have endured far longer than anything that weighs on you now. And as the night settles deeper, those cycles feel even more comforting. The moon's light becomes softer. The air grows still. Your thoughts begin to drift. The steady motion of the cosmos becomes a kind of lullaby, one written in gravity, illuminated by moonlight, and carried across billions of years to find you exactly where you are. You can rest now, knowing that the same forces that trace the moon's path will be there tomorrow. The same balance that steadied Earth will still be holding. The same rhythm that has guided nights for billions of years will guide this one too. Rest now. The moon will keep watch. You've traveled far tonight, across time, across gravity, across the quiet mechanisms that keep your world steady. Now the story returns to where you are in this moment, in the soft darkness of your own evening. The moon above you carries every chapter you've just heard, but right now, it offers something even simpler. It offers rest. You don't need to think about tidal forces or ancient collisions anymore. You don't need to hold the weight of cosmic history in your mind. Let it drift away, like the moon drifting outward each year. Let the big thoughts settle. Let the quiet rise. Look at the night around you. Feel how still it is. Feel how your breathing slows when you allow it to. Feel how your shoulders ease just a little when you stop reaching forward or backward in time. The present moment is enough. The moon knows this. It has practiced stillness for billions of years. When you let yourself match its pace, the noise inside you softens, the tension loosens, and the day begins to dissolve into calm. You've learned tonight that the moon's stillness is an illusion, but the feeling it gives you is real. Something in its gentle light helps you settle into yourself. Something in its patience helps quiet the parts of your mind that try to move too fast. You don't have to chase anything right now. You don't have to solve anything. You don't have to carry the entire arc of your day into the quiet hours of the night. Let the moon hold some of that weight for you. There is a kind of philosophy written in its glow, a reminder that motion does not have to be hurried to be meaningful, a reminder that balance does not require perfection, only persistence. The moon has been tugged, stretched, reshaped, and slowed, but it found a way to settle. So will you. Not all at once, not in a single moment, but gently, over time, in the same slow rhythm that guides the tides. The moon doesn't worry about tomorrow. It doesn't fear the changes to come. It doesn't hold on to the chaos that shaped it. It simply follows its path, steady, patient, present, and you can rest inside that example. You can let yourself be here, breathing, unwinding, allowing the night to soften whatever sharp edges the day left behind. Feel the stillness spreading through you now. Not a forced stillness, not a rigid kind of peace, but a natural one. Like a tide that rises without effort, like moonlight that lands without sound. Every inhale brings you back to yourself. Every exhale releases a little more of what you carried. There is nothing you must do for the universe to keep its balance. The earth will keep turning. The moon will keep drifting in its ancient arc. The tides will keep their rhythm. The seasons will keep their pattern. All the vast mechanics you've listened to tonight will keep unfolding exactly as they have for billions of years, without needing your concern, without needing your attention. You are free, in this moment, to let go. The moon holds its place in the sky, not because it is unchanging, but because its changes are slow enough to feel like comfort. Let that comfort settle around you now. Let it wrap the sky above you in quiet. Let it soften your breath. Let it remind you that the world is not asking anything of you right now. This is the part of the night where thought dissolves, where stories fade into feeling, where the steady presence of the moon becomes a kind of shelter, a companion for the hours ahead, a gentle guide toward rest. So breathe. Sink into the calm you've been moving toward all evening. Let the moon keep watch over the sky, over the world, over you. Everything is in its place. Everything is moving in the slow, patient rhythm the universe has practiced since the beginning. You can close your eyes now. You can let the weight of the day drift out of you. You can let yourself fall toward sleep, knowing that the same cosmic balance that shaped the moon's stillness is holding you too. You are safe. The universe is quiet tonight.